Hi, this is Manuel, Delta Lima 2, Mike Alpha November. I've learned through software downloads that we had for the uSDX that we have right now in the range of 3,000 uSDXs out there in the wild, being used by radio amateurs all around the world. Makes me very proud. Thank you for that. Thanks for supporting us along the way. So I figured it's time for another video where I explain you how to use that little thing. So I'm going to walk you step by step through the screen, the options, the knobs, and yeah, what can we do with it? What's the settings inside for it? What to watch for? Let's get started. So let's start from the very beginning. The top side, the rotary knob, the menu button, enter button, PTT button. I mean, that's all what's written on there. On the left side, we have a USB-B connector, which serves as a power supply, USB power supply, and can be used to upload firmware. And also, it can be used to control the rig via CAT commands. The CAT commands for the uSDX are compatible to the Kenwood TS480 protocol. For details, you should look in the forum, forum.dl2man.de. We also have a 3.5mm jack, which is used, to control external PA. This is actually just a switch. It's basically the same thing like the ICOM IC705 to control external PA. You can just switch the PA on. This makes sure that no RF is coming out from here before the PA is active. Now we are already on the right side. We have the SMA connector, which I always apply SMA to BNC adapter. Then we have the microphone key input, where you can attach your Morse key, your pedal, also external microphone, and audio, where you can connect headphones and active speaker, because the onboard speaker is not very good. By the way, we have also onboard microphone, which is actually pretty good. You need to know about that there is an internal 270 ohm resistor that is activated once something is in this jack. So this reduces a little bit the audio, and it's less easy overdriven. Yeah. On this side, we have the main power connector, 12 volt. It can take up to, I would say, 16 volts, and as low as like 7 volts. If you use 5 volts, I would suggest going over the USB port. And here in the front, there is, you can see it only from the inside of the housing. This is sitting like so. There is a little bit of a thought cutout. If you need, you can cut that out, so you can program the rig via the ISP, which is inside here. Okay, so let's say you need to open up the housing to do ISP programming because something went wrong. It's enough to unscrew these 4 screws, then you can remove this side of the housing. Okay, let's switch it on and go through the menu. So, just for the fun of it, I have changed the uSDX, and I've reset this uSDX so we can have a look at what it looks like when it's completely brand new from the factory. It should be showing your call sign here, which is important later. In case you don't have it here, I'm going to silence that now. This is our very first move and our very first trick in manipulation. Just rotating the knob is just changing the frequency. If I press and hold it and rotate the knob, I'm lowering the volume. This here is the call sign, your call sign. If you don't have it, then you can download first of all your firmware. You need the serial number for that. It should be written on your bag that it comes with. With your serial number, you can download your firmware and assign a call sign. That's the only way you can get your call sign in here right now at this point. So when you want your call sign here, and it's important later in the menu, I'm going to show you where, then you need to update your firmware. So we have that upper left corner, which is showing your call sign, the upper right corner, which is showing the S meter. Left, we have the A indicator, which is showing which VFO we are on. We have A and B. This is the main frequency section. Here we have the mode section. Here we have the frequency, the bandwidth, the receiver bandwidth section. And right here, the R is an indicator of the status. So R means it's on receive. Now, if I press the menu button, menu 1.1 is volume. That's very obvious. It does, if I now enter this, I can do that by pushing the center button, rotate it, increase the volume. And now I see a lot of people jumping out via menu. That's one option. This cancels, saves and cancels out from the menu, but there's a more clever way. You can go change what you need, and if you want to continue inside the menu, just press the center button and you can roll to the next menu option. Mode can be selected. This has only here in menu LSB, USB, CW, FM, AM. By the way, FM, AM is not available in the quick scrolling through modes options I'm going to show you later. 1.3 is the filter bandwidth. This has also a shortcut. Well, by the way, in CW, this is, I'm going to show you later. There's a simple trick. Band can also be selected via combination of buttons. Tune rate, that's an important one, can also be set via shortcuts. I'm going to show you that later. VFO, we have A and B. There's at this point not really a sense to that. It's just we have that option for later. You can switch them, you can have separate frequencies in them in case you want. Some people maybe use it for a split operation. So VFO, A, RIT. RIT is an interesting thing. In case you probably CW operator, and in case you hear a station or you're sending a CQ and your QSO partner is replying on a different frequency, up or low, so outside of your filter, you can enable that RIT and then you can tune it. But also I will show you how to do that by buttons. It's a way easier way to do that. AGC. So the AGC does regulate the receiver sensitivity, the input sensitivity, depending on the input signals. If you switch that off, which can be done, then the volume option also acts as receiver sensitivity. So keep that in mind when you use it. AGC on. Noise reduction. That is a very simple noise reduction algorithm. However, it only works in SSB, not active in CW or any other mode. It can be switched from 0 up to... Oh, that's nice. Doesn't work anymore. Okay, it's inactive in that software. Then we have attenuator. Two attenuators actually, 1.10, 1.11 attenuators 1 and 2. Those are two different attenuators that can attenuate your signal. They use different sections of the receiver to make that happen. However, in the standard setting, the attenuator will be set to 0 decibels and attenuator 2 will be set to 2. This is the standard setup, and it's usually set this way because we found that the ADCs for the I and Q input have the highest dynamic range when set to this settings. So attenuator 1 at 0 and attenuator 2 at 2. However, if you have strong signals nearby, or if you find you have a deaf radio or a little bit underperforming radio, you can play around with that and can maybe get out something more. However, mentioned again, this is the best all-round setting. S-meter. Now, here Guido has built in some very nice options. Standard, it is set to dBm, but we can also set it off. So we have no S-meter. We can set it to S, which is showing a number like S9, so you can just read it out. That's what I used most. S bar, so we have a bar graph. That's a little bit like QCX. And words per minute, which is interesting. If you have a CW decoder active, it will show you actually the words per minute it's counting from the received CW signal. That's a very nice gimmick Guido has built in here. Okay, the next is also very interesting, SWR meter. At this point, I need to make you aware that SWR meter is only working right now in CW mode. It is not working in SSB mode. The reason for that is we don't have enough time while generating SSB speech. So the processor is actually at full load and cannot do the SWR measurement, which is a receive thing, while generating SSB. So at this point, only working in CW and also only working in straight key mode. However, there's a workaround with the latest software. If you press the PTT button, it will, after a series of 8 DITs, will go into key down. So you can also see it there. Now let's see what this menu has for us. SWR meter off, that's one option. Forward SWR, this means it measures the forward power and the SWR. It's showing in the upper right corner. Forward and reflected power. This is power, output power and efficiency, and power and voltage. So in case you run from battery, this is an option to see how your status of the battery is. That's basically it. Well, in case you are outside, want to see your SWR, you see your power and your SWR. And this is usually the way I set it up when testing a rig. Okay, let's move forward. CW decoder is on by default. Semi-QSK, that's, yeah, you can simply try that out. That's a CW option. If it's off, you can hear between your DITs and DARs. And some people like that, some people are annoyed by that. In case you put semi-QSK on, there will be no receive audio in between your DITs and DARs, and it will basically use the same time as your TX offset, which will be one of the next options. We have keyer speed, which is obvious. We have if you choose to use a key or pedal, then you can set your keyer speed here. Keyer mode, here you can select if you use a straight key or iambic B, iambic A mode. Keyer swap if you're like me and use thumb for DAR, and you use a standard setup pedal, then you can swap your keys here. Practice mode, that's an interesting one. If you set that on, then you cannot accidentally transmit. I'm doing that when I connect it, for example, to a nano VNA or something directly where there's no protection, or where there's a high risk that I blow something up, or even just when I play around and I have no antenna connected, like now, I can put it to practice mode and have no danger because PA is completely deactivated. It also, you can use it as a CW practice device. I will show you in a minute. So, sorry, practice on. The next is Vox, which is obvious. Vox is voice control over microphone. Some people use that for cut control. So something is coming in from external line in. It will trigger the transmit. Noise gate. this is noise gate is not only a function that is using or controlling the microphone sensitivity level, it's also the thing that controls the Vox Vox level. It was called Vox before, I guess, or Vox level, and it also triggers something around that. Right now I need to, I'm never using that option, I'm never changing that, so I'm stumbling a bit here. You probably realized by now. If you really want to know what it is, write me a posting in the forum, and I will ask Guido again what exactly it does and all the connections in between. TX drive, now this is an important one. TX drive 4 is the best found or round compromise. So it's standard setting. What it does is it determines the linearity, basically, of your SSB transmission. If you put it to 1, the SSB transmission is very linear. So if I whisper, it will create less output power, and if I shout, it will create the most output power. 4 is, for a QRP rig, the best around compromise. However, if you want to crack a pile up, you can crank it up all the way up to 8. However, I would not recommend to do that, because even if a needle falls down, it will create full output power, and you will have no longer any amplitude information in there. Only phase information. So 4 is already explained, a good all-round compromise for QRP SSB transmission. I would recommend leaving it there, or in case you have different microphones, different setups, different sensitivities, just play around that 4 level. Never crank it full up or full down. TX delay. Now this is what we need in conjunction with PA, external PA. This is milliseconds, and let's say I want to switch on my PA 30 milliseconds before my CW goes out. You will recognize a little bit of delay when you're using the pedal, but that's the safety for your PA. So now if I let it at 30, this means my PA will be switched on and my CW key up will be 30 milliseconds delayed. CQ interval. We have here 5 seconds. You can put that higher. 10 seconds, for example. This means if we go to the next message, I told you your call sign would be important later. This will be automatically stored in your CQ message. You can edit that, you can change that. However, this is how it comes when you download the firmware customized for your call sign. And if I start that loop, sorry, going to make it a little bit louder. Now let's go to the menu again. If I start it, if I'm at that menu point, I'm not inside the menu for editing it, like so, going out. If I'm in that menu and press menu again, it will start securing the message. I'm going to do the interval really short so you see what the effect is. It will call CQ for me. And by the way, I have no antenna connected. I'm in practice mode, so nothing goes out. So I can stop that by simply pressing the menu again. Okay, now we have more internal options. PA bias min should actually never be changed from 0. This is the minimum bias we can get in SSB transmission or also in CW, the minimum, the 0 level, basically. This should always be 0, obviously, but the PA bias max, you can play around with that. But be careful, I need to warn you here. Because if you mess that up, you will mess up your PA. Because if I crank that all the way up to 256 or whatever, this means my PA FETs will always be switched on. And this means they will burn immediately. So don't do that. 128 was found to be the best all-round compromise for 3 BS170s. This is the optimum point where the gate is switching. But we have other FETs available, like how it's being called, FDT 86256, I guess, where I found out the optimum PA bias max is at 160. So you can play around with that a little bit, and you will obviously also see, because every FET is different, that your best efficiency might be at another value. You can just play around with it and measure efficiency. You will see that there is a point where you have the highest efficiency, and this is how you can play that. I've heard that people said you can regulate output power with that. I would not recommend that, because we are having a class EPA inside here. This means that there is an optimum working point, and if you screw that up by changing the PA bias, this means you get less output at the same input current. Basically, you're ruining your efficiency. I would not recommend that. If you want to change the output power, the best way to do that is to change the input voltage. That's the most efficient way. That also goes for if you want higher power. Let's say you have only like 4 watts at 12 volts, and you want to have that 5 watts, so crank it up to 13.8 volts. Or let's say even worse, you're only getting 3 watts, but you have super efficiency. You can crank it up all the way to 16 volts. However, do not overdo it, because the PA FETs cannot handle much abuse, and if you're trying to squeeze out 10 watts or something like that, you're asking for trouble. I wouldn't do that. Stay around the 5 watt region, you're safe. 6 watt also fine if you have good SWR, but if you have bad SWR, I would rather go lower from the voltage and the output power. Reference frequency, I made another video of how to calibrate that. That basically, I get a lot of forum mails or direct mails or requests. Hey, my frequency is off, what can I do? This menu point 8.3 is the option where you can fix that. If you change to the reference frequency, this means your display will be aligned to the reality. The shown frequency will be aligned to the reality. Background to that is every crystal has a little bit of a different behavior, and with that menu you can adjust that. So, okay, next menu point is Shunt. This is something I get a lot of questions about because it's nowhere being documented. This is except for the forum. Shunt has something to do with the way we are measuring the efficiency. We have a IC on the RF board. I can probably show you if I find some. Yeah, this is it. This is the IC where we measure current, the PA current, and this uses a PCB track, a shunt track, and by adjusting this, oh, sorry, I need to explain further. There is variations when they produce them in the factory, and the resistance can change of that track because of tolerances, simply manufacturing tolerances. And so your efficiency calculations are still accurate. You can manipulate this value here. This is some kind of debugging feature in case you find that your rig shows more or less efficiency than you determined in reality. Every rig I check, I do external testing. I measure power, output power, input current, input voltage, so input power, output power, and calculate efficiency from that. And by the way, I subtract always the RX current before calculating the input power, because I only want to know the PA efficiency. And then I adjust Shunt, so the shown values in the menu match what my external measurements are showing. That's that. So this is a relatively new menu point, low pass config. Standard value is low. Low is yeah, what we released initially. This means you have the lower bands, 80, 60, 40, 30, and 20 meters. By the way, if you change that, make sure you have the right low-pass filter board attached, because if you change that for high or for classic and you have the low-band RF board on there, you will ask for trouble, because it does nothing else but assign a different slot to another band. And let's say while the first relay is 80 meters, do I lie to you? No, actually K1 is 20 meter for the low band version. And if I set it now to the high band version, it's trying to run 10 meter through the 20 meter relay, and 20 meter through the 80 meter relay. So this is assigning a different set of frequencies to the relays. This means in order for that to work, you need another RF board that has the RF section for the bands you have. Check my website. On the assembly page, there you can see what setups are possible, and other RF board setups will be available soon. Just to walk you through, the low band version I told you already, 80 to 20. High band is 20 to 10, so 20, 17, 15, 12, and 10 meters. And the classic band version is the compromise between that. It's 80, 40, 20, 15, and 10 meters. But as said before, you need another RF board for each option to work. So don't mess with that in case you don't have another RF board you want to attach to that. So, and the last thing is the firmware version that is shown in menu point 9.7. In my case, it's 2.00H, so a little bit of an older version. Okay, now to the shortcuts. The knobs, because we only have basically 3 that play with the settings, have multiple functions. There are different options assigned. If I press the center button single, you can see a small dot walking through. Now it's here. This means where is my digit to manipulate. See, now it's at another digit. Now it's another digit, and so on. If I double click that button, that center button, it will change band. If I push and rotate it, it will change my volume. So these are the functions here. And the enter button does change my mode. Single click, double click changes my bandwidth, and long click, long press puts me in RIT mode. And now you can see how I can manipulate it. And by the way, you can also scroll through the steps that are being used. So now you can change that. And another long click goes to VFOB. Now you see it rotates through. Huh. Now VFOB A again. So basically that's it. Yeah, can probably still show you quick how the CW decoder works for practice mode. It will also decode your own stuff that you send. You see, CQ. Okay, that's it. I've already talked a lot and probably used a whole lot of space, and the video will be extremely long just because I talk and talk. But hey, in case you want to know everything, you need to explain everything. Okay, I hope you enjoyed it anyway, and I would if you like my content, if you like to support us here, please subscribe to the channel, leave a like, leave a comment if you have any questions, and yeah, see you on the bands. 73, good luck, bye bye. Delta Lima 2, Mike Alpha November.